All right, where are we picking up off? We just started graphing, right? Remember, we're in the algebra textbook right now. Yes, I still owe you a midterm. Don't worry about that. You always get instruction in terms of where to go with that. So you're not going to be minimized or reduced time or anything of that nature. You should still be studying chapters 1 through 7 with pre-algebra, right? My suggestion again was the chapter exams, right? Chapter exams, as they have at the end of every chapter. And what we're doing now in the meantime, while we're doing that, because we're not going to stop lecture since it's going to be a take-home midterm anyway, we're continuing on with the algebra because you're going to need it anyway. And it's going to help you remember, remind, even a little bit of a review in terms of what's going to be happening or what will be your midterm as well as the final. We solved algebra equations and now we're on chapter 4 with the graphing, right? And this one, again, it's not difficult because everyone has graphed before at one point or another. It's just remembering all these little details that are supposed to make graphing a lot easier for you. So if you look at your notes, right, let me share the screen really quick. If you flip back to your notebook and you maybe you look back 1 or 2 pages or whatnot, you saw that there were 2 things I wanted to mention before we start today. That we talked about the quadrants, like what the graph, the grid, the coordinate plane, you'll hear a lot of names for it, looks like. And then the fact that we have 3 ways to graph right here, that table of graphs, right? And X, Y intercepts and slope intercept form. And normally I would blast through all 3 ways to show people how to do it, but I think it confuses people a little bit too much, right? So what do we do instead? What we're going to do is I'm going to follow the flow of the textbook because that's what I was reading before everyone was starting. And it looked pretty decent. So we were looking at a table of graphs and I demonstrated one. We'll do another quick one, but then we'll talk about a couple of properties, okay? So that was Monday's lecture. Here's today's lecture, right? And we're going to say graphing continued. Right into another easy example. So here's example 1. I'm going to say graph using points. Let's do something negative this time. So we'll go y equals negative 2x. Let's go plus 1. All right. So there's our y and x, right? And as usual, you can draw little markers for yourself. When you find that you'll graph, you can just create something on your own, right? You don't need a printout graph sheet or anything like that. You can easily use a credit card or your ID or something to make these little ticks and just eyeball it basically, because you're just looking for the best prediction, but not, you're not graphing for super. You want to graph for accuracy, but if it's like a smidgen off or whatnot, it's not the biggest deal in the world. So then you draw your X and Y. Then remember, only takes 2 points to find a line. However, they as in teachers, textbooks, tutors, all that nonsense, always suggest to, do 3 points. And I always start with points that I work with, right? So say something like -1, and I'll do them different colors so you can see 0 and a +1. And then those are X, right? Remember, X is always input. I'll write it up here, input. So that means that's your plug in. And then your Y is your output. That's always the same, no matter what book you're talking about. And this is your calculated. Right? Plug in, calculate. Plug in, calculate, plug in, calculate. Not a big deal. Okay, so what do? You plug in the x to where you see x. So a -1 times -2 is +2, plus 1 is 3. 0 and 1, and then -2 and 1 is -1. All right, so you graph these points. What do I have there? -1, 3. Remember how I wrote the points next to the, I'm sorry, the coordinates. Remember they look like this technically, -3. That's what these are called. These are called coordinates. If no one has taken the time to point it out, I wrote them on the graph themselves from the last example, but I'm not going to do it this time though, because one, you have it color coded so you can actually see it, but two, it gets really clunky in terms of the graph. So 1 and -1. Okay, those are your 3 points corresponding with the 3 colors, and you get a line that looks something. So you can see, obviously, I'm a little bit off in terms of the points, but you get the general idea. You get the gist of how it's happening. Don't forget your little arrows on the end. By the way, I'm not going to mark you off if you forgot those little arrows. When you see your final, they all have the arrows. It's just something to keep in mind. And then this is your answer, right? This is it. They'll ask you, hey, graph using points or graph this graph, and then they'll give you the equation and an example of this on the final is that they'll show you 4 different graphs, and you have to be able to determine which one is the correct one. Okay, so that's straightforward. Now, what happens when you have special graphs, right? Remember, I gave you the definition of a linear equation. So I'll say here really quick, recall.
Professor?
Yep.
Um, real quick, sorry. How
No,
do
don't
you
be
get
sorry.
the numbers again?
Which numbers? The X numbers
Like
or the Y
the
numbers?
XY graph.
Okay, so these on the left, I picked. You can pick any 3 numbers, but I choose easy numbers. So if you had picked, say, 1, 2, and 3, you would have gotten the same graph. It's just that you would have used different points. So this is, I picked randomly. The numbers on the right side, or the Y in other words, right? These come from calculating in the equation. So if we look at, I'm going to color code with purple here. If we take, I'm going to actually get rid of this recall. If we take our
So you
equation
put
right
the
here, yep, I do y equals
so basically you
-2
plug
and
it in.
then, yep, that's why I wrote
Okay.
right there.
Okay. Thank
Just
you.
like that. Yep, no problem. It's a +2 plus 1 y equals 3. And then you do the same for all 3, right? So that's it. If anyone for a brief moment goes, wait, where these numbers come from, So I pick them. I pick the ones on the left because I always pick the easiest numbers. In fact, that's what any teacher will always tell you. If you ever had to graph like this, they would say, pick easy numbers. Pick -1, 0, 1, or 1, 2, 3, or 0, 1, 2. Why would you pick 100, 101, and -26 if you didn't have to, right? This makes it really easy, makes it concise. Now, what I wanted to, did I answer your question, by the way? I think it did. Okay. I mean, she said thank you anyway. So remember when I said, oh, right, there's a formal definition of a linear equation, right? So I'll write recall now here, right? The formal linear equation is, they said ax plus by equals c, and both x and y can't equal 0. So I'm going to scroll up. Have you take a look at that. Remember, that's our last definition. And before people go, oh, do we have to memorize this? It's like, well, no, not really. Because when you perform, do, oh gosh, how else can I say it? Practice, right? When you're doing these problems, you actually do them and you don't realize that you're abiding by the rules, right? However, a trick question for you, say example 2. I'm going to ask you first is the following. Linear equation. All right, so I'm going to give you, oh, I don't know, y equals -2. So I said, hey, recall this little bubble. That doesn't really look like a bubble. And I wrote a couple more things, right? A, B, C are real numbers. If you go back to the definition where there you flipped it back from your, what do you call it? Your notebook, or you, what do you call it? Flip back in your notebook, or you look at the previous PDF in our notes, or if you look on the content section and you pull up the previous lecture, whatever the method is, right? I gave it in fine detail. Hey, this is the linear equation, right? Now, my follow-up question, now if you already know this, great. But for those that don't know, right, I'm posing now, is the following a linear equation? If I just gave you a plumb or y equals -2. And of course, if you know already, you can send me a private chat so I can see who knows it later, right, on WebEx. Obviously, I can't see it now. If I flip to it, I will see it, and then people will see the answer, so I can read that later. But for those that maybe don't know, it's a 50-50 chance. It's yes or no. What do you think?
No.
Okay, and then why do we think it's no, if you don't mind sharing?
Because there's like no parentheses
Mm-hmm.
giving you like the second step or something like that to do. Like there's no, so that you can form a line, something like that.
Sure. That's one way to go about it, right? There's no, if I'm understanding this correctly, when you say parentheses, there's no other numbers or variables to work with, right?
Yes, there's no other variables to work with. Correct. Yes,
Right.
thank you.
Yeah, no worries. So there's nothing else to work with. And then you kind of go, okay, well, what is there? You're leaving out things, okay? And here's the thing, right? Even though you don't see it, let me rewrite it up here for people to see. Even though you don't see it, let me copy this. AX plus BY equals C. Okay? Anyone else, before I move forward, anyone else think yes, this is a linear equation? Nobody? All right. Well, buckle your seatbelts because you're about to have your minds blown right now. So it actually turns out that this is a linear equation, and it's totally valid to go, hey, but you left out a bunch of crap for me, right? You didn't give me another variable, you didn't give me another number, you didn't give me anything to work with, all right? And I'll go, fair enough. Sure. I totally believe you, right? So now, if you look above, right? Let me use a green color here. So this guy in purple that I gave you, I told you, remember, you didn't have to memorize this, you just had to recognize it. And then if I draw a nice little line going over here so you can see it. Nope. So let's match, if you will. So let's start with the easy stuff. do green now. What's C in this case when you look at y equals -2 in black versus in purple? Let me write it a little bit neater here. So I write it right above so you can see ax plus b y equals c. All right, what's C in this problem in corresponding to the black?
-2.
-2, right? Okay, so this is good, right? C is equal to -2. Okay, y matches with y, but we notice that there's no number in front. But technically there is. What is B in this case? So again, the y matches the y, which is cool. B says, hey, there must be a number in front of me. And then you look at the original equation I gave you, y equals -2, right? And it's like, oh, but there is no number. But then you look again, you go, wait, technically there is a number. What's that technically number?
Is it 1?
It is 1. Thank you. And it's not thank you for giving me the right answer. I mean, that's always appreciated, but thank you for responding. Okay, now here is the nuance, if you will. I'm going to just tell you this. What's x? You're going to tell me there is no x. You didn't give me another variable. And then I'm going to say, well, I didn't. Yet, if you look closely at this statement, both x and y can't be 0. So y is not 0 because you have y. Y is there. But since x is empty, that means x is definitely 0, right? So how do you make it 0, right? How do you do that? How do you make it where x is 0 or whatever the case may be? There's 2 ways to look at this, right? And I'm going to write this in light blue. You can think of this as either, actually, there's only one way to think about this. Whatever your A is, it doesn't matter because x will be, actually, no, let me think. I think the best way to think about this is that if you plug in any x, yeah, so let's do it this way. Since it's 0 here, right? I hope everyone understands this is 0 because it's empty. There's actually 2 interpretations to go with this. You can think of this as, and I'll write this out so people can see what the hell I'm talking about. So this block right here in this grayish blue, I'll draw another arrow. So if AX 0, then what happens? Then either A equals 0 or X equals 0, right? So let me take a moment to explain this. Hopefully everyone understands that when you're looking at this equation, you're going to go, oh, okay. I see a y, I see a -2. Everyone goes, all right, cool, that makes sense. And then I asked you, hey, what is the b in this case? And you said, oh, it's y. It's actually the invisible nonsense that all mathematicians like to discuss or talk about or whatever the case may be. And it's like, okay, cool, that's good too. Now, all of a sudden, you're going to tell me that, wait, professor, you're going to tell me that all of a sudden now there's this invisible 0 that's going to be representative of the x? I don't believe you. Or if you don't believe me, you need more convincing. I say that's fair, right? You would go like, hey, I want to be convinced more. I don't think this is sound logic, as some people would say. All right. So how do I fix that? How do I convince you? Okay, so that's the problem I'm posing right now, or I'm telling you so that you could be aware of where I'm coming from. Now, how do I explain it? Well, it turns out that when you have 2 numbers that multiply equal to 0, you can have two options, technically three, right? You're saying that either a is 0, because if a is multiplied by any x, you're going to get 0. You can also say x is 0, because that means x multiplied by a, whatever the number is, you'll get 0. Or you'll get that the third one that I said technically is that or a and x are equal to 0. So those are our three options, right? So you go, okay, that kind of makes sense. I think it does, right? If you have 0 and it's made up of two things and you're multiplying, it's either one is 0, the other is 0, or both are 0. Okay, so hopefully everyone's following right there. Now, what is it? What does it have to be? Okay. Well, here's the great thing. Even though the a here, it looks like a variable, it's actually a constant variable. Constant variable. And I'm going to do this. I'm going to put variable in quotation marks. I'm going to underline constant. That means that whatever this supposed a is, it's an actual number, but it has to be the same number. An example of that is when you have an equation like this. Let me use green here. E.g. y equals 2x. So see that 2 in front of the x, which mimics this a in front of the x? In this little baby example here in green on the right-hand side, right? We're going to have baby examples here. You can see that no matter what x or y gets calculated or plugged in, the 2 stays the same. So that's what I mean by constant. For this particular example, right? Here's our example. It's in this navy blue, right? It's the y equals -2. We're talking about this specific example, this problem only, that y equals -2, that our constant variable, whatever it may be, right? It can't change. It will change for every example we have. That's why I looked at the baby example here, y equals 2x. But for this particular example, y equals -2, right? Whatever that made up number is, it can't change just for this example. Now, if you say that x is equal to 0, right? This is your proper variable. Sorry for the outdoor sirens. This is your proper variable. This is an actual variable where you don't know the number and you plug in a variable, right? So our baby example for that is saying n, or a number n, a number n. So you see a number, you don't know what number it is. It could be any number in the world. It's n. They just call it n. It could be 1, it could be 2, it could be 10, it could be 1,000,000, it could be 1,000, it could be 102, it could be -6, it could be whatever the hell number you want. But the point is that it's an actual variable where anything can be plugged in. Whereas the previous example, y equals 2x, the constant variable is that 2. In this little baby example, it's n. And then, of course, at the very bottom, I said 0 could be from a or x. It could be both as well. Now, what is it in this case? Now, why did I take the opportunity to say all this? And a great thing about this is that, remember, this video is going to be recorded. So if this doesn't make sense, just kind of, you don't have to write every single thing I'm writing. Just kind of take it in, if you will. That's normally what I say in class, in person. I go, put everything down, pencils down, phones down. Just listen to me, humor me by trying to take this in. So what's the point of showing you the difference between the AX that we see here, that I told you that for our original equation, again, I'll start from the beginning, we were given y equals -2. I asked you if this following equation is linear. Someone gave me no, they gave me their reason. They were valid reasons. And it turns out that this is a linear equation. The answer is actually yes. Answer. Yes. Now I'm talking about the why. Okay. Well, the short answer is like, well, because I told you, but who wants to use that? The concrete answer is like, well, it has to match what was in the purple box. AX plus BY equals C. It has to match that form. And now I'm trying to explain to you, why is it that the 0 there that would take up the AX, why it works. And this is why it works. The way it works is that if you look at A equals 0, it has to be this reasoning. And the reason is that if X is 0, that means you have nothing to plug into here, right? So I'll say that right here. If X was truly 0, we have nothing to plug in. And then you might go, well, I don't know what you mean by that. That doesn't make any sense to me. Well, let's graph it, because then it'll make sense, right? So what does the equation y equals -2 look like? It looks like this. It's trying to tell you that you have a y here, and you have just this crazy long x, and it doesn't matter what number you plug in. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And I'll even take the time to label these numbers. -1, -2, -3, -4, -5, -6. Of course, zeros in the middle. 1, 2, 3, 4, 5. We're here with -1 here on the vertical, -2, and of course 1 and 2 on the top. All right, so take a deep breath in and then breathe out. And then we go, okay, how do we graph this? Well, I just said that your x, even though it's blank, it technically isn't 0. It's the a that makes it 0. So in reality, your equation probably looks like this. So I'm going to draw another arrow down, going down here. So your equation probably looks like this instead. 0x plus y equals -2. And why is that? Okay. We need a number to plug in still. And you go, well, there's no x there. It's 0. It doesn't matter. Why does it matter? Well, it technically does. And this is why. Suppose for a moment that we plug in 0, right? And we'll make an XY chart as well. Sorry, I'm trying to keep everything on one page because I want to keep this all neat. So I'm gonna use different colors now. Let's use pink first. We plug in 0 for x, and we're looking at this equation that's next to the chart, right? The 0x plus y equals -2. And someone humor me. If I plug in 0 for x, what does that turn into? The 0 times 0. turns into
0.
0, right? Which means that y is equal to what?
Y would be equal to 1.
Try again. So if 0 times 0 here is 0, as someone said previously, then the remainder here, y is equal to what?
0.
Look again. The underline, the pink underline.
Oh, excuse me, it's -1.
All right, one more time.
It's
I know what you're
-2
saying.
still.
It's -2, right? I know what you meant by -1. You're just reading the number, but you probably just said the wrong number. That's all. I know what you mean. So yes, it's -2 right there, okay? So again, in pink right now, I'm doing, okay, what's 0 times 0? Someone already told me it's 0. So then what does y equal? It's -2 because that's the only thing that's left, right? So -2. So I'm going to erase this now. We're going to do a different color now. Let's do this light blue. Let's be a little bit more crazy, a little bit more interesting. Say x is 5, right? I go here and I go, hey, what's 5 times 0, everyone? 5 times 0 is what?
0.
0, but then that leaves us with y equaling to what again?
-2.
-2. You're like, okay, this is really boring. I see what you're doing, but you're being kind of stupid right now. Let's do it one more time, but then this time pick a really weird number. Let me do orange now. No, not orange. Let me use this aqua blue. Say I chose a weird number like -2.5. Well, what's -2.5 times 0? We get
0.
0, but then that leaves us with y is still equal to what?
-2.
-2. So now let's plug these numbers in and see what the hell's going on. So -2.5 and 2, -2 is right about here, right? Everyone agree right there? -2.5 is right there. The other numbers are a little bit easier, right? 0 is -2. Oops, my dot's too low. Let me fix that. I couldn't see. And then last but not least, we had 5. Right here, ballpark. All right, now the home run question, right? The big question now. Now that I've established to you all that, you know what, you can't really make the variable 0, in this case x, it had to be a, because you have to plug in numbers. What do you think happens when you plug in any x for this equation y equals -2? What will be the result every time?
A straight line.
A straight line. A straight line along what number, though?
Along the -2.
Yes, right? So again, that those that are answering, again, I wholeheartedly appreciate your answering. And if you already knew it, bravo, kudos. You're probably like, oh my God, Professor Law is just giving me the same shit again, right? And I apologize for that. But for those that are kind of like, wait a second, I've seen this before, but I don't recognize it, or maybe I've forgotten it, or I never was explained, right? Hopefully your peers or your classmates are answering this. It's slowly opening that aha moment. But the point is that no matter what x you plug in, you're always going to get -2, despite this 0 being there, right? So you're going like, well, it doesn't matter because I always get 0. It's like, yes, you do always get 0. But the reason for that is that no matter what x value you plug in, you always get 0, and it always gives us y equals -2. So your answer is actually not only a straight line, but it's a straight horizontal line. All right? And in fact, this will always be the case for any single variable example. Now, normally the textbook will go, oh, let me do it with x equals now and show you the difference. No, I'm not going to kill your brains like that. I feel like this explanation is great because it goes step by step to unveil what's happening. And now I can just write down the rules, right? This is the visual case for those that need it. And then now I can just give you like the actual rules. So here they go. So what do we learn, or what can we take away? I'll leave this there so people can see it if they're still copying or whatever the case. I can go, okay. An equation has a single variable. Notice that we're talking about the coordinate plane here, so we're talking only x and y. That's what I mean by a single variable. You can't pick a random variable like K, J, B, C, D, whatever, because we're not talking about the ABC plane or the JK plane or some crap like that, right? We're talking about the X, Y coordinate plane, right? So it has a single variable, and I'll put in parentheses here, X or Y. Then it is still a linear equation. So that's what we want to establish first. Now the rules. Also, if the equation is y equals a number, then this implies, remember, an equal sign with the arrow means implies. This implies a horizontal line. Horizontal line. At the number off the y-axis. Why? Or how come y? Well, because it's y equals a number. So you draw a horizontal line, it has to be off the x-axis. I mean the y-axis. I just messed up. The y-axis. In our last example, it was y equals -2. You look for -2, you draw a horizontal line. And then you're like, okay, well, which axis? Well, the y-axis, because it's y equals. All right? Now, if the equation is x equals a number, then it is a vertical line number. I'll scroll up just a touch now. The, as you can imagine, x-axis. All right? So if you follow this, you'll get it right every single time. Now, there is something that I have to mention, though, that I'm going to talk about prematurely, just a smidgen, but you can keep it in the back of your head because we won't reach it today. And that's this. So just a heads up. For the first example, if the equation is y equals a number, right? That's why I put a number sign. Horizontal line at the number off the y-axis. Just keep in mind that slope is 0. The number 0. Actually, no. I should write 0. Like, you know what? Let me write it out. Slope is equal to 0. And then underneath that, if the equation is x equals a number, it's a vertical line at the number off the x-axis, whatever the number that is, right? I'm going to write slope is undefined. And we will talk about these concepts next week because we're definitely not going to reach it today. But just keep that in the back of your head. I'll even put in parentheses. But everything in black, though, is absolutely true, which means that if I scroll down and I say really quick, hey, example 3, and I said x equals, I don't know, -1, and then I drew a quick graph like this, y, x, right? 1, 2, 1, 2, -1, -2, -1, -2. You would tell me that it is a straight line, obviously, but vertical or horizontal?
Vertical.
Vertical, correct. Now, at which number though? Off of which axis? Which axes?
The x-axis, negative
Yep.
at -1.
Yep. So then you just go like this, and then you're like, done, boom. These are like the best kind of questions you can get into in a final because they're the easiest to identify, they're the easiest to recognize, and there's no ifs, ands, or buts about them. So it's pretty straightforward. All right. So we did a review in terms of graphing using points. We use that same concept to describe what it's like when you have a single variable equal to a number, which is still linear. So it turns out it is still linear, right? The concerns that were brought up, like, hey, you didn't give me this, they were absolutely valid. And it turns out that we didn't need them. That's why this still works, okay? So that's great. And thank you everyone for your participation by showing it. What questions do we have here about just the nuances of special graphs like this x equals y equals, or graphing with points in general? Because then I can move on to the next method.
I have a question.
Yeah.
Will this be on the exam too?
This will be on your final exam, but not your midterm.
Okay.
So what will happen is that, remember, the midterm is only going to be responsible for the textbook, because right now I have to give something. It's just like, again, and I'm apologizing. I know I'm profusely apologizing. Yeah, I'm still apologizing that, yes, you are going to get something and it's going to be really, I guess, if you will, basic. But this stuff, we're going to start doing homework on it soon. I just don't want to pile up homework right now when you should be studying for what should have been the midterm like a week ago or so. I mean, I'm going to try to shoot for it at the end of this week. But then I'll start assigning problems like this so that people can practice them, because the midterm won't take you a week. I'm just going to give you a week just to be fair. Okay? I'm doing that for all my classes. But no, this is on the, but it will not be on your midterm. All right? What other questions? Remember, this is just plotting and graphing. All right, cool. So this then leaves us to, this is everything you need to know more or less having to do with the charts, plots, graphs, plug in your points, connect the dots, right? Now we go to the second type of way, or second alternative to graphing, and that's
Excuse me?
using what's called, yep, go ahead.
Someone asked, is the midterm, is it next week?
I'll try to release it at the end of this week.
Okay.
Basically, whenever it gets posted, you get a week to do it, right? It's not week specific, it's time specific, if that makes sense. Okay. Were there any other questions that, you know what, I can probably check now. Where's WebEx? Midterm is next week. Cool. Okay, cool. All right, perfect. What other questions? I don't want to feel like I'm brushing off anyone. So this means that darn, is this stock underperforming right now? All right, so this means that we have to move to our second method of graphing, right? So here I'm gonna call it second method of graphing. This is called X and Y intercepts. Okay, so what do? In fact, I'm probably going to grab an example from the textbook so I don't spend my time racking something really stupid and give you a really bad example. So I have the textbook already pulled up. This is what I was reading before class was starting. I was just kind of sitting there doing my own thing. They show you examples of whatnot. So let's look at an example they're going to give here. 2x plus y equals 6. Perfect. So this is example 4. Graph using, sometimes you'll see people say informally, just saying intercepts. Graph using intercepts. Intercepts with a T. And the equation was, what was it? It was 2x plus y equals 6. Okay. 2x plus y equals 6. So how do you do this? Well, you still make a chart, but it's just a super baby chart. Again, I keep on using baby, but that's okay. So first you make a chart. Here's the unique thing about the intercept. You're going to plug in x for 0. And you're also going to plug in y for 0. Why are my AirPods running out of battery so quick? Okay. So you see what I did there? I plugged in x for 0, which means I'm going to calculate for y. And then I'm going to plug in 0 for y and then calculate x. So this I would actually will write out by hand so you can see what's going on. So first, in the first column here, now let's do it this way. I'll draw an arrow. So we got 2 times 0 plus y equals 6. So what happens? This cancels. We're left with y plus, I'm sorry, positive y, or y in this case, is equal to 6. Which means that y is equal to 6. Done. Okay, what about the other one? Again, I'm going to draw it out for you. So now, instead, we have 2x plus, not y, but 0, 6. Okay, well, what happens to the 0? Well, nothing. I'm going to scroll up. Nothing happens to the 0. That's gone. That's trash. That's just 0. Okay, but what do you do to get the x by itself? Well, you have to divide both sides by 2, don't you? And then this implies that x is equal to 3. Plug in your 3. So what did we just do? In short, we plugged in 0 for both an x and a y to calculate their respective, what are called intercepts. Now there's a little bit of finite or fine tuning, if you will, in terms of what does it mean to be an intercept, which I'm going to describe right now. But once you see, what do you call it? Blah, 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 blah. Once you see what I write and as well as what I draw, then it'll make sense. So let's start with the writing first, because that's always annoying. So here, nope. Come on, I want an arc. Okay. Whatever. Okay, here, the intercept, this is again called an X-intercept. X-intercept. And for this example, it's not just the number 6. It's not just number 0. It is 0, 6. It has the whole point or the whole coordinate, right? 0, 6. Okay. And what this means is that this is the point where, you know what? No, I lied. Typo. This is the y-intercept. There you go. Y-intercept. I apologize. Fix that, please. It's supposed to say y-intercept because there's a number where the y is. And then if people are saying, what do you mean by y? remember that each coordinate point is represented with x comma y, just as a heads up. So let me finish this. The point where the graph crosses the y-axis. So it's kind of weird, right? You plug in a 0 for x to get the y-axis. So you just kind of have to think backwards a little bit. Okay. What about the 3 comma 0, right? This is called the, as you can imagine, the X-intercept. And it is written as 3 comma 0. And again, this is the point where graph crosses the x-axis. So remember, I forgot who it was that said on Monday, but they said, oh yeah, the minimum number of points you need for a straight line is 2 points. Well, it doesn't get any easier with these intercepts, right? In fact, any line that crosses, any line that's not horizontal or vertical will, at one point or another in the future, cross an x and a y axis, right? So that's a little tidbit right there. So how do you graph this? Well, it's actually quite easy, right? You just kind of draw your line so that you can compensate for how big the numbers are. So in this case, it's going to be like this. This is x, this is y. I know that in the y direction, I have to go up 6. So 1, 2, 3, 4, 5, 6. In the x direction, I now have to go out 3, 1, 2, 3. So here's my point, right? 3 comma 0, 3 comma 0. Here's my point up here, 0 comma 6, which is right here. And I can draw my orange line between them. That's pretty crappy, actually. Hold on. No, that's not good either. Why can't I get this right? I hate how I can't undo it at the point I need it to be at. There we go, that's good. So that's your equation, 2x plus y equals 6. Sometimes you'll see books do that. They'll rewrite the equation next to the line. 2x plus y equals 6. So you can see here they streamline the process of, if you will, choosing your points. Remember how earlier I said, hey, someone asked, how did you get -1, 0, and 1 for your x values, right? And I said, I just chose them. It's like, whatever, right? Doesn't matter, just choose easy numbers. Well, here you can see that, that when you choose the intercepts, they already predetermine the points you use, right? You plug in a 0 for x, and that gives you the y-intercept, and you plug in a 0 for the y, and that gives you the x-intercept. And sure, there's a little nuances here in terms of definitions, but as long as you keep on doing it this way, and yeah, you may accidentally call it by mistake like I did at one point, and you go like, oh, I mislabeled or misinterpreted, but as long as you do the math correctly, right? 0 for an x, 0 for a y, calculate your variables correctly, you'll get it right every time in terms of the intercepts, which are right here and right here, and then you'll graph it correctly every time as well. Okay, we're going to do one more example here, but before we do, what questions do we have here? It's supposed to be easy. What makes it difficult is when the numbers don't play as nicely as you see here, right? And I'm going to pull one from the textbook so you can see exactly what I'm talking about. Did they give you all whole numbers? That's kind of misleading. Oh my god, they do. They don't give you any fractions? That's kind of lame. Oh, yes, they do. Here we go. I'm going to pull one from the homework here. So y equals 1/4 x minus 1. Okay, that's good. Example 5. Let me keep some of this information here so you can see. Y equals 1/4 x plus 1. 1/4 x, right? 1/4 x minus 1. That's fine. Plus 1 is fine too. All right. So what do, right? We go x chart, xy chart. Use your colors. Doesn't matter what color you want. So just remember, if you put a 0 for the x, you're finding the y-intercept. If you put a 0 for y, you're finding the x-intercept. And again, I'll take the time to write out the equation. So you have y equals 1/4 x, parentheses x, plus 1. This goes away, and you're left with y equals 1. Done. That one's easy. But what about this other one, though? So now I'm going to write 0 equals 1/4 x plus 1. How do I solve for x now? Depends on how you want to go about it, but the easiest way is probably just to subtract 1 on both sides. So you're left with -1 equals 1/4 x. How do I get x by itself? Well, you have to multiply by the reciprocal, remember? 4 over 1. But if you do that on the right side, you got to do that on the left side, 4 over 1 as well. So you see, that's some fractions that you don't want to forget. Fraction play. And then you're left with what in this case? You're left with just x on the right side, right? Because everything cancels here. That's 4 with 4, that's 1 with 1. And then you're left with just a -4 on this side. So you're left with -4 here. So even though the equation looked weird, the number still came out whole number. In fact, since the entire textbook gave you only examples with whole numbers, I imagine that you're only going to see intercepts with whole numbers as answers, which is kind of misleading because what happens if you get something weird like a half or a third or 2/3 or something like that? You can graph it just the same way as well. So it's a little misleading, but it's fine for now. Do the same thing, right? Y, x. You know that you're going to have to go up 1 space in the y direction. You know you're going to have to go out 4 spaces in the -x direction. So you're left with -4, 0. And then you're left with 0, 1. And you can see that this particular line, it's quite steep. I'm sorry, shallow. There we go. It's like a ramp. Ramps are shallow. And again, this is your equation, y equals 1/4 x plus 1. All right. What questions do we have here, if any? You okay here? All right. So this leads us to what will be our next section, which is understanding the slope of line. They show you visuals of this, but do they introduce the equation immediately? I don't think so, actually.
Professor, really quickly, the answer is what again?
The answer to the intercepts are
Why?
these answers right here. So they are
Got it. Okay, I got
0,
it.
comma 1, and then
Uh-huh.
-4, 0. But the actual problem is actually asking you to graph. Sorry, that's what I was trying to say. Makes sense?
Yes, got it. Thank you.
No worries. What other questions? All right. So what I was attempting to show you was that they're showing you how the slope behaves, but I think it's easier if I just show you the equation and then we can explain it, and then it makes a lot more sense that way, right? Because they want to show you in terms of a visual first. That's why you see these little pegs right there and how the movement works. But I have a way of teaching this, so it's fine. This should be our last topic for the day because it's introducing something new and then also to practice it as well, okay? So what do? Here is our definition. Okay, and I want to say this. Given two different points, let's call them x sub 1. So you see that little 1 on the bottom, that's a subscript, right? It's a way to distinguish one x that is not necessarily the same as another x, right? So you'll see right now, x sub 1 comma y sub 1 and x sub 2 comma y sub 2, right? In other words, you got 2 points and they are in the form of x comma y. And the reason we write it out with the little subscripts is to show that this x right here in purple is different from this x. They could be the same, but they are not necessarily the same, right? So I'll say that again. They are both points, right? X comma y, but we have to give the distinction of x sub 1 comma y sub 1, and the same thing for the x sub 2 y sub 2 is that they could be the same points, but they are not necessarily the same points, right? They could be the same, but they're not, or they don't require to be the same. And again, the subscripts are supposed to help you distinguish that. Okay. And then that's that. So given two different points, this and that, the slope formula, I'll write this in purple, slope formula, so call it, or slope between 2 points, is ... So it's like this. Here comes the formula. It is M stands for slope in algebra, equals y2 minus y1 all over x2 minus x1. Now, a big purple square, so you definitely want to know this formula, right? You want to make sure that on your study sheet that you're slowly making for what will be your final, that you have this written somewhere. I mean, yes, obviously you're not supposed to be doing this, what do you call it? You're supposed to be doing this not open book, but you didn't hear me say that per se. And what else? Yeah, you need to be able to recognize this formula and manipulate it and do what you need to do with it, right? All right. All right. So what's an example of this, or how does it look like when you have to use this equation or manipulate it or whatever the case may be, right? I have to show you what it means, and I also have to show you what it does visually as well, okay? So let's do that. Let's pick an easy example that I can think of. We're on example 6 right now. Okay, so I'll keep this formula up here. And here I'm going to write example 6. And then I'm going to say find the slope between, let's say, what's an easy one here? Let's say 0,2 and 1,4. Now, when you were first introduced to this, most teachers, students, whoever, several people, right? They always talk about ways to make it a lot easier to approach, if you will, right? And the number one thing that students find helpful is that they label immediately their 2 points. Now, it doesn't matter which one you call x1, y1 or x2, y2, because you'll find out that the formula will compensate no matter which way you go. However, I can tell you that most students, what they do is that they go x1 like this and y1 like this, and then x2 and then y2 like that. So they always use the first point for the ones and the second point for the twos. But like I said, as long as you label them properly, it doesn't matter who's 1 or who's 2, as long as they're labeled properly. Because then the next mistake that students generally do is that they write down the formula. As always, I personally suggest when we're working with formulas to rewrite the formula. So I know I have it in this big purple box right here, but I'm going to scroll down and I'm going to rewrite the formula again. y2 minus y1 over x2 minus x1. So I always tell students, I encourage them, hey, rewrite the formula first. It's only going to help you. And the second thing is that you want to make sure you pick and choose the numbers correctly so that you don't get mixed up in between. So y2 is 4, so I'm going to color code this. I'm going to subtract y1, which is 2. And then x2 is 1, which again, I'm going to color code. And then x1 is 0, which is this. And then you do the math like normal, right? Like a regular fraction. 4 minus 2 is 2. 1 minus 0 is 1. So the answer is 2. However, before you think of this as just regular 2, it's better to think of it as 2 over 1. So this is the final answer, but why is it important? Why does it help us? What's the point of this? What's the visual take? All that fun stuff, okay? So this is the answer, but a couple of things to point out. There's some properties that are involved with the slope, okay? Let's list them out. So when you see this, this essentially translates that the slope is made up of y values over x values. Wouldn't you agree? Right? It's a difference between the y and the difference between the x's on the bottom or denominator. You also see it as sometimes as a triangle y over a triangle x. The triangle stands for the change. So in mathematics and physics, when you see a triangle or delta, it means change, right? So again, this delta here is the change in the change in. Okay. And last but not least, sometimes you'll see the slope referred to as what's called the rise over the run. So at one point or another in your algebraic life, you're going to find out that they've always talked about your slope, your algebra, your equations, whatever you like to call it, in some shape or form like this, right? And what happened is that go, hey, this is what the case is, and you may remember one way versus another way, and you might, oh, I don't know, you might only recall certain things one way versus another way, depending on how the teacher taught it. And it just depends on what sticks with you, right? Now, with the rise or run, I really have this really cute way of doing it because my master teacher, that's what they call them when you're teaching in high school, whoever the veteran teacher is, she showed me this little thing where you remember rise because bread rises, right? And of course, if I'm talking to students that are a little bit older, I tease about it going like, well, it's like when you bake brownies or bud brownies or you're baking with weed, right? You just watch the bread rise, right? So you can always remember rise connotation with baking, right? Because flour rises when you're baking. And then running, it means that you're running to the right or left, depending if you're positive or negative. So normally I have this little stint where I run in place and I demonstrate for the entire class, and it's kind of funny, and people go, haha, you know, all that fun stuff. But you don't see me doing that right now. Or maybe I can do like a stupid YouTube video of it and just post it for you, and it'll be like a 20-second clip, and it'll be like a nice meme or something like that. But it will rise over run. Now, what does that look like when you actually draw this? Because all this equation or all this told us was that, hey, this is a slope of 2 over 1. What does it mean visually? Well, let me draw it for you. I'm going to draw a little bit bigger so that people can actually see it, because if I draw the graph too small, you won't be able to see it. So I'm going to split the page here. See that blue line? So that people can see what the hell's going on here. You know, no, I'm going to draw in the center. All right. And I'm going to be as precise as possible when I'm graphing this. So again, my points were 0, 2, 1, 4. Okay. So I'll just go out 4. Now I'll go out 5 in each direction. 2, 3, 4, 5. 1, 3, 4, 5. 1, 2, 3, 4, 5. All right. And in fact, I'll even zoom in as well. So let's plot these points. So we got 0, 2 in green here. So here, 0, that means no left or right, and we go 2. So there's 0, 2, right? Good green blob right there. And then I have 1, 4. So that was in light blue. So 1, 4. Big blob here as well. So again, this was 1, 4. And this one is 0, 2. Make sure I did that right. 0, 2, 1, 4. And it told us that the slope is 2 over 1. So imagine, if you will, you're a little person. Let's draw you in pink. Okay, my headphones are dying. Let me take them off. So imagine, if you will, you're a little person, right? And you're standing right here where the 0, 2 is. Sorry, let me zoom in. So you're a little person in pink right here. I'm only going to draw a stick person because that's all I can draw. Right? And then you have to walk over this grid, right? Because don't draw this part. But imagine, if you will, this is like graph paper, right? You got lines going like this. So you got a grid, right? But I'm not going to sit here and draw the grid because, well, we don't need to, right? We can visualize this. This is like as if you had graph paper. So let me erase all these. But imagine, if you will, we're in the grid, right? And what happens is we were told that our slope was the 2 over 1. So I'm going to draw it on the side here. Hey, remember that our slope, m, is equal to 2 over 1. But that also means we're going to rise and then run. Which means what? That means that if you're walking, right, and you're this little pink person, you rise means you always go up. Why? Because bread rises. Just remember, bread always rises. Bread always rises. So you go up, right? So you're going da, 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 1, and you go up 2, da, 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 2. Right? So you've completed the rise. So check mark. You've gone up. Now you run. Which way do you run? Well, if you're running to the right, it's because you're positive. So you run right, for positive. You run left, oops, for negative. So what do you check if it's positive or negative? You check the slope here. So 2 over 1, when we did our answer, I'm going to zoom out. See how it's positive 2 over 1? So that's a positive slope. So in this case, 2 over 1 here, let me zoom back in. This is also positive. So that means we're going to run to the right. So after we've risen, or we rise up, right? Then you're going to run to the right. 1. And lo and behold, without any voodoo or magic, you can see that we ran to the right, and it leads to our next point. That is not a coincidence, right? The fact that I gave you, sorry, let me zoom in again. The fact that I gave you 0, 2, and 1, 4, or 0, 2, 1, 4, right, is that you're finding the relationship between the two, right? What's the slope, right? Or what's the change in them, right? And it's 2 over 1, or in this case, 2 over 1. So that means you go up 2 and you move to the right 1. This also means that with slope, you can predict the next point as well. So the slope is going to be the same this entire line because it's going to be the same line. So if I draw this line really quick, hold on, let me zoom out for it. And let me just try to make sure it's straight as possible. Okay, that's the best I can do. Right? It means that using the slope, you can predict what the next point is without having to calculate it. So you go up 2, right? 1. And I know I didn't draw another tick, but imagine, if you will, I did. There's 2. And then your next point is right here, whatever that might be. So in this case, what does it look like it will be? Well, it looks like it's going to be 2, right? Because you can see that it's going to align with that. And then it's going to align to the left. So that's not 4, but it looks like 6, 2, 6. Right? And you can continue to move up 2, 1, 2, 1, 2, 1, and you can actually build your graph visually, graphically, however you want to think of it, by doing this, right? And I'm not saying that you have to, but how can you know if your next point, 2, 6, is correct, right? Well, if you take 2, 6, and this becomes your new x2, y2, and then you subtract it from either 0, 2, or 1, 4, right? It doesn't matter which one you choose as your x1, y1, right? You can have a choice. So choose either. Not both, though. Choose either and make them your new x1, y1. If you do the math, and I'll do it really quick right here on the side, you're going to see you're going to get the same answer. So whether you do 6 minus 2 over what is that? 2 minus 0, or you do it in blue, right? You go 6 minus 4, looks like, over 2 minus 1. So let me pause for a second. Everyone see where I'm getting these numbers from? So first and foremost, the 2, 6, right? It's a third point. Where did I get it? I got it in pink because from the 1, 4, since I found out the slope was 2 over 1, I knew that I could find my next point by going up 2. That's why you see these 2 little dotted lines, and I moved to the right one. I got 2, 6 because that's what it aligns with on our graph right here. Right? This is number 2, and you can see this is 1, 2, 3, 4, 5, and this is 6 right here. I know I didn't draw a tick mark, but you get the idea. You can see it visually. And what I'm trying to explain right now is that how do you know if this answer is correct? Well, the original slope was 2 over 1, and you can see that, what do you call it? You can see that if you pick that new point, 2, 6, and you find the slope between either of the original points, whether it's the 0, 2, which I wrote in dark green in the first, or 1, 4, which I wrote in light blue, let's see what happens. Well, you get 6 minus 2 is 4, which is over 2, and that simplifies to 2 over 1. Or on the bottom here, you get 6 minus 4, which is 2, and 2 minus 1 is 1. We get the same answer. So that means that it was the correct slope all along, right, when I calculated. And once you find the slope of any point, or I'm sorry, find the slope between any 2 points, you can always build out your graph. That means that if I moved, essentially, again, I'm going to zoom in, and I moved up again, 1, 2, and then I went to the right 1 point or 1 unit, I can find the next point as well. So you can always build your graph without even knowing what the graph equation is. And that's supposed to be like a really cool thing, right? That if you're given 2 points and you don't know what the hell the equation is, but you find the slope,
you can always build up to the next one. Now, I know that some of you will probably look at this and go, oh, wait, couldn't have I gone down 2 and to the left 1? And the answer is yes. If you're out, now this is what I always have to tell all my students. If your algebra is very sound, right? In other words, you're really good, right? You just got in this class because you didn't take the SAT seriously, or you took the first day exam and you didn't study enough. And you're like, whatever, I just got stuck. And it's not that you don't know this, it's just that you didn't perform on the tests. And that happens sometimes. It happens to all of us. If you go like, oh, I actually do remember this, I just don't care for it, which is fine. You're not going to hurt my feelings. But if you remember and you go like, oh yeah, I could have gone down and to the left, that works too. It's just that when I'm teaching this, I always teach the rise or run, so that for those that, whether they are, they're nervous about this, or they are, I don't know, whether they're nervous or they are, they're nervous or they are, they're indifferent about it, or they feel anxious about it, then you're kind of like, oh, okay, cool. That's okay. This will assure that you will always get the answer correct. Okay? So that's that. All right, what questions here? So again, this is the visual take on it. Let's do another quick example where I just pick 2 random points, and I'll use negatives this time. So again, this is the visual explanation here. Visual. But when you see a question that says find the slope between the 2 points, they're not asking for all this. They're asking for just the number. So an example is, if I give you example 7, and I just gave you 2 random points, like -1, 5, and -2, -3, and the instructions tell you to find the slope. Now I can do this a little bit faster, right? You just label. You label x1, y1, different color, x2, y2. What's the formula again? It is m equals y2 minus y1 over x2 minus x1. Then you plug in your numbers. Purple is -3. Now you just have to watch your negative signs, right? -3 minus, black minus because it came from the equation, regular 5 in this case. So that's easy. That's okay. Now watch the denominator though. Whoops. You have now a -2 minus in black because of the formula, but then you have a -1. So you got to fix the -1 like this. So notice how the numbers stay the same, and the negatives also don't get riled out, or they don't get messed up, or they don't get, however you want to think of it. Nothing gets mixed up, right? Everything stays the same, and watch your signs and all that jazz. So then now it becomes just like a regular problem, right? You get a -8 on the top, -3 minus 5 is -8, and then you get a -2 plus 1 now, which means it's -1, it looks like. -3 minus 5, -2 plus 1 is -1. Yep, and then your answer is actually not -8 over -1, but it's actually 8 over 1, or 8, or just 8 by itself. But realize that it's helpful to keep it in the fraction form so that you realize you're talking about the rise over 1, because if you see just 8, yes, that is the correct answer. However, you may forget about the rise over run, right? You might forget that, oh, right, slope is in terms of fractions. That's why fractions are actually extremely helpful instead of decimals when you're graphing, right? Cool. So you have a visual explanation of, what slope is and how it represents between points. And you can see that the purpose of the slope is that you can build out your graph, even though you don't know what the equation is. And this is just another quick example of the calculation. Normally when people talk about slope and you're doing it in an algebra course, you're talking about like calculating slope. But for the cases where you have to graph or you have to do something and they say use the slope to find something, this visual is very, very helpful. And again, you can rewatch this again. You can rewind, or I'm sorry, not rewind, fast forward to the end of the lecture so you can rewatch or re-understand, reiterate this so you can get a better grasp. All right? And then, in fact, you can draw the same graph using these points as well and make sure it works. It'll be good practice for you. All right? What other questions do we have on graphing so far? Or what we've learned so far? All right, good. I'm going to stop the recording right now before I unnecessarily record any longer. Stop.